Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this Security Boulevard Roundtable. My name is Cody, and welcome back to TechStrong Learning. Before we dive into things, I do have just a couple of housekeeping notes to review with everyone. First of all, we are recording our session today. So if you happen to miss any of our conversation, if you'd like to watch again later, or if you'd like to share with the rest of your team, we'll be sure to send you an email with a link to access this recording on demand. Now, if you'd like to get involved into our conversation today, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we do want you to direct those to the Q&A tab on the right side of that chat section. Today's roundtable is going to be very conversational, so send in your questions when you have them, and we'll do our best to weave them into our thoughts. Now, we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, your questions, and to fill out our post-webinar survey. That is attached in the handouts, but we'll post the link toward the end of our conversation. So today's topic is securing open source. And I'm joined today by Himil Kadekia, engineering manager in the Paranoids group at Yahoo. We're also joined by Kyle Kelly, security researcher at Semgrep. And keeping this train on the tracks is our very own Mike Vazard, chief content officer at TechStrong Group. So Himil and Kyle, thank you both so much for joining us today on TechStrong Learning. Mike, would you like to dive us right into our conversation?
Sure will. Thanks everybody for joining us. Let's just get started right away there, and I'm going to direct this over to Himil. But what makes open source software more challenging to secure? Because frankly, it's code, and we have code everywhere, and we have commercial code. But is there something about open source that kind of leaps out at us as it's just fundamentally more difficult? What is it that we need to be thinking about here?
Sure. So open source in general offers a lot of advantages, right? Be it transparency, collaboration, flexibility, or even community support. But these advantages also pose some challenges, as you mentioned, right? So for example, let's talk about transparency. Since the code is freely available for developers, researchers to review, this can lead to faster identification or resolving of some security issues. But the downside is it also is available to attackers for exploring potential vulnerabilities. So promptly addressing or identifying vulnerabilities like Log4j shell is quite important in open source. Also to add to that, right, since it's open source, it's highly customizable and users can modify the code based on their specific needs. So I think it's very important for us to make sure that we do not introduce security vulnerabilities through either poorly implemented customizations or integrating third-party components without checking the security risks or if they have any unknown security risks. So Kyle, what's your experience? What do you think out there as well?
Yeah, so from my perspective, open source software security is problematic largely just due to the scale of it. So if you look at 2022, the GitHub Octoverse reports suggest that there were over 52 million new projects created on just GitHub's platform in that year alone. So when you start to consider other platforms, we're talking many, many, many millions of different open source projects being deployed. And then also just the simple fact that even if there are vulnerabilities detected, and oftentimes they do become discovered and reported properly to the maintainers, it's then up to the people using those open source dependencies or projects to actually update them and use the newer version with those vulnerabilities remediated. So oftentimes reports suggest that more than 90% of known vulnerable packages that are being used actually have a patch available to them already. I mean, we still see Log4j, as you mentioned, still roughly, I think it's around 25% of downloads are vulnerable downloads. So we need people to actually use those patched versions.
Emil, just to follow up on that point a little bit, it also seems to be with open source projects, my forks have forks, and there's a lot of different projects that are kind of semi-related to each other. and they have shared vulnerabilities. So how do you kind of keep track of all of that and knowing whether or not you're actually using something that is vulnerable?
Yeah, that's a good question, right? Like, so there are a lot of tools and services available, right? Like, so the biggest thing when you're using an open source software is to have something called as a SCA tool, or software composition analysis, where it keeps a track of third-party dependencies or open source libraries, and it informs the users, and in some cases even opens a pull request for you guys to use the latest available library version, so that you always use the up-to-date version of the library, which reduces the security factor, the number of vulnerabilities you are exposed to, and also make sure that you are up to date with all the libraries or patches, as Kyle mentioned, right? Like, if they are available. But with that being said, right, along with using SCA, the developers and the DevSecOps need to make a better effort to make sure the whole SDLC pipeline is more secure. So there are not just libraries, but we have third-party Docker images, for example, or applications which we people directly download from Docker registry or any registry in general. So we want to make sure that we secure those endpoints as well. So as you look at a SDLC pipeline, we have different pieces, right? We've got the source, which is where the developers use and build their GitHub or build code. Then it comes down to build itself, your CI/CD pipeline, and your CI/CD pipeline needs to be more hermetic, and you don't need to have access to internet, because once you have access to internet as part of your CI/CD, it opens a big can of worms where people could download stuff from online while doing CI/CD, and you don't have control over what's being downloaded. So I think in general, along with source and build, we need to also look at the deployment part of things and make sure you don't download any open source software, or ensure that you have secured artifacts or signed artifacts during the deployment time, which would make the whole SDLC process much more secure.
Yeah, Mike, you mentioned the forked projects. That's something that's scary. That's probably like one of the things that keeps me up at night, because you look at something like NVD and all these vulnerabilities and security advisories that are published for projects. It's like, great. Now we know that if you're using this package or this project at this version, we can associate a vulnerability with it. Well, the worst advice that I give people is, if you want to get rid of all your vulnerabilities, just fork all of those projects, and now there's no known associated vulnerabilities with that project, because it's a unique project once it's forked. So, the way I look at it, CVEs just aren't really created to handle that type of ecosystem where projects may still have that known vulnerability, but now it's forked, and so you lose the association, and that's really scary.
I can just declare myself vulnerability free by essentially establishing another fork. Kyle, you follow this space pretty closely. We've seen threats come and go over the years. Are there things going on out there that are getting your attention right now that are new types of threats that people should be on the lookout for? Because I think we've all been around this block once or twice. So, what's keeping you up at night?
Well, besides the fork dependencies or projects, I wouldn't say they're really new threats. It's just more of, malicious actors, they're like water. They follow the path of least resistance, or electricity. So I feel like endpoints used to get hit really hard, but now we have pretty competitive EDR solutions, endpoint detection response solutions, that help mitigate those risks. And they're also seeing developers and development environments as a pretty high value target. And so I'd say particularly North Korea seems to be really focused on malicious dependencies by embedding malicious code into either well-reputationed packages, or creating packages with similar names to kind of compromise people through typo squatting and things of that nature. And so I think malicious dependencies is on the rise. I think it's only going to get a lot worse before it gets better. And I say that because the market for those types of products doesn't seem to be overly saturated or with a lot of demand. There is definitely demand, but it's, we see things like SBOMs skyrocketing thanks to government support, but there's not much pushing for malicious dependency detection yet.
Emil, you got anything that you're kind of seeing that's new that you haven't seen before in this space that you're going, wow, these guys are getting crafty?
So I think it's not really new as such, but supply chain attacks are on the rise with SolarWinds and even Log4j shell, right? Like, so based on the recent Sonatype report, which was published recently, they mentioned that the supply chain attacks have increased 200% over last year in general. And there are more than 240K malicious packages out there which are not being fixed. So those are some of the things which are quite important. And as Kyle mentioned, right, like injecting malicious codes or vulnerabilities due to distributed downstream changes, there needs to be more guardrails or safeguards in place to make sure that those packages either are built correctly or we have fixes in place, or B, if those are being used, we need to make sure we use the patched versions of these. So supply chain attack is one thing which I'm actually interested in, and that's what we focus as well, to make sure at least we catch some of those.
Yeah, and I would add that a lot of these risks seem to kind of, the root cause, I would say, comes from the way that we're handling public package repositories. So not to pick on any specific one, but there's NPM, Maven, the long list. Pretty much every language has their own ecosystems. But most recently, we've seen the Open Source Security Foundation, OpenSSF, as well as the US government with CISA kind of partnering to work on investing and building out more security capabilities within these public package repositories. So hopefully, we'll start to see more awareness of malicious packages and also just less malicious packages in general. I mean, NPM lately has just been flooded with, if you go to NPM right now and search for Roblox, you pretty much get 10,000 malware samples. And just like a couple of weeks ago, there were 800 packages removed from NPM, which were all just bits and pieces of movies. So my joke is that NPM's the new Pirate Bay. You can distribute whatever you want from NPM.
There you go. Well, Tamil, to Kyle's point, are we just too trusting of open source software? I think we spent a better part of 2 decades just going to town and reusing as much software as we could, and lo and behold, it turns out that there's issues.
I wouldn't generalize that developers or we are universally too trusting. There would be some subset of developers who would be overly trusting and just download open source software, but those can lead to security risks and vulnerabilities, right? Like, we don't want to blindly trust any software before we actually download stuff, right? We need to make it sure it's vetted by security experts at your company, or at least as a developer, you want to vet any open security vulnerabilities. If you see an S0 or an S1 or a P0 vulnerability, you want to tread carefully and make sure that whether that open source project has been maintained, when was it last updated, has it been updated by some remote guy in some place in Nevada, or has it been actively being used in the community, right? Along with that, we want to also make sure that we reviewed the code thoroughly, right? It's, again, as a developer, you've got other things to worry about as well, I would say, instead of just thoroughly vetting each and every open source code. Especially there are libraries which are dependent on each other and third-party libraries. But having security experts or some steps in your SDLC pipeline to ensure that you are vetting your code, having source code reviews, or with AI coming in, you could have AI code reviews which would flag for maybe secrets or any kind of suspicious code. That would make it much more trusting, I would say, and reduce the dependency or the bad name which open source has for vulnerabilities, I would say.
Yeah, I've always viewed software development environments as the Wild West. Frankly, it's might be a hot take, but most of my background's in consulting for financial institutions, banks and credit unions, things of that nature. And so, for years and years, there's been a hard set belief in users cannot download or install anything they want. We do not let people be local administrators. We don't let them install a tool just because it's convenient. It has to go through a vetting process. Whereas if you look at software development environments, there's very few organizations out there that actually evaluate every dependency that's being pulled into the dev environment and potentially into prod. And so that's concerning to me. Emil, you mentioned AI being a tool, so I'll mention a way that it could be used negatively is a lot of people are using ChatGPT, for example, to generate code. Well, ChatGPT will oftentimes use software dependencies, pretty much always will. And at least in the earlier days, I'm starting to see it less and less, but it would just make up a dependency, one that doesn't exist. So it'll, in the Python code, it'll say import such and such package. Well, that package doesn't exist. And so a malicious person seeing that ChatGPT is oftentimes recommending this could very easily create a malicious package under that name. And now ChatGPT is going to be recommending developers to download malware, which is a scary thought.
Well, I'm shocked and appalled that AI platforms are hallucinating. I mean, it's just unbelievable. But Emil, how do we go address these issues? And I'm asking the question because if I'm the maintainer of an open source application or project, I'm doing this generally out of the kindness of my heart. It's a hobby, and I didn't ask you to go download it and build it into some major enterprise application. And so now suddenly there's a security issue, and you're calling me up on, late night on a Friday, going, "Hey, can you fix this?" And the answer is going to be, "I'll get to it next week if you're maybe." So how do we kind of build an effective ecosystem here, realizing that A, the people who built the software might not be security experts in the first place, and B, a lot of these folks are not getting paid to sit around and maintain this stuff.
Right. Yeah. So this is like a contentious issue, right? Like, again, paying for open source project is not how open source project operates on. It brings in the dynamics of conflict of interest and how do you prioritize patch building if you start adding monetary value to a patch being built. But to shout out, right, like OpenSSF and CNCF have done excellent work and are promoting projects in the open source ecosystem. You might have noticed a lot of good projects coming out of both of these, OpenSSF and CNCF in general. And as you mentioned, like open source project has been traditionally been maintained by volunteers who contribute their time and expertise out of passion, but not just because of monetary gain. That gives up for them. It gives you a recognition in the community. It's giving back to the community, and I would say compensating would be a good way to incentivize for building stuff. But instead of directly incentivizing the developer, there should be funding and sustainability on the open source project, because as you notice, more than 1.1 million or more than a million projects are not maintained actively. So by having right funding in place and maintaining those projects which are heavily used would incentivize folks who are not contributing to contribute more, and also make sure that the open source is not dying down, especially the projects which are being used.
So Kyle, do we need to be more careful about what open source software we use and evaluate it based on how active that community is and how quickly it is able to address the need for a patch or whatever it might be?
Yeah, and there actually was some sort of scoring system that was being developed. I don't know if it's still in the works, but they were looking to sort of give a score to a package based on the community side of things, like how many maintainers are there and how many downloads does it get, things of that nature, which I think is really effective. Personally, I think if you are simply updating your packages and only using packages that are well maintained, you're going to be 95% better off than everybody else out there. So I think those two simple things get you very, very far.
All right. We got a couple of questions from the audience that I'm going to start throwing in here just to keep everybody on their toes. But I think it was Kyle, but I'm not entirely sure, made a reference to malicious dependency issues and why can't scanning tools kind of solve that issue? What's the root cause of that problem?
Yeah, so I mean, SCA tools will definitely be involved in detecting malicious dependencies. So at least my definition of SCA is simply obtaining the list of relevant components that make up a software application. And so that's definitely important when trying to identify malicious dependencies. But personally, what I see, the value that I see the most when it comes to malicious dependency detection is detecting it before it's ever downloaded or brought into the project. And so using something like a proxy, that when a developer goes to import a package, that package should be evaluated in real time or compared to some sort of heuristics and say, hey, this package looks suspicious. I'm not going to let you download it. Because while detecting malware is great, if you detect it after it's already compromised your environment, it's less great. So
I think that was an ounce of prevention equals a pound of cure kind of thing.
yeah.
All right. Well, Kyle, what is your sense of how much of the software that we have installed in production environments is actually vulnerable because of all these open source issues? Open source is everywhere. So are we, have too much of a good thing going on here?
So the direct dependency vulnerabilities are likely to be less than 10 or almost definitely less than 20% of your vulnerabilities if you are to use a software supply chain security tool. Where using an open source package often introduces vulnerabilities are through transitive dependencies. So GitHub did some research for JavaScript specifically. And so for the average project that was importing 10 direct dependencies, it wound up downloading and leveraging 683 total dependencies. So those 10 that you're using directly also have their own dependencies, which you have to download. So it gets very messy very quickly. And those transitive dependencies are usually where the vulnerabilities lie.
Well, that's great. Just like in real life, my dependencies have dependencies, right? Hamil, there's a question here, and I don't know, but it seems like probably not, but I'm going to ask it anyway. But do we need to pull back from open source? Do we need to focus more on commercial software? I mean, or is it just too late? The horse is out of the barn and we just got to go?
Yeah, I think it shouldn't be a general blanket, I would say, to decide whether to use open source or a licensed product. Just we need to evaluate the benefits and risks. Again, open source has numerous advantages, right? Cost effectiveness, collaboration, flexibility, as I mentioned earlier, right? On the other hand, with licensed product, you get support, you get licensing, you get dependency management, vendor support, right? So we need to assess our risk and make sure for some cases, yes, licensed product makes sense because you get vendor support and you need to have those in place. But for things which are readily available open source and are actively maintained, I would say open source is a very good choice. And if you look at the statistics, it says more than 80 to 90% of company software is using open source projects. So again, open source is here to stay. It's not going away. It's just how you use it and how careful you are when you are downloading third-party dependencies or having right checks, as Kyle mentioned, right? Like there are dependency chains and transitive dependencies, but if we have SCA tools which handle those and give you the latest patch versions, that would solve a lot of your questions, basically.
All right. And to be specific, I think we also have a question from the audience here, but they're asking Carl, which I assume is Kyle. What tools or preventative solutions do you suggest for flagging malicious libraries during the actual download by the developer? Because that seems to be where the point of interaction is. If we get to that, then the rest of this doesn't become an issue.
Yeah, I don't know. Hamil, maybe you know any solutions out there that might be doing that? I know we've experimented with it at Semgrep. I know there's tools like socket.dev and Phylum that are really heavy into the malicious dependency realm, but I don't know if they're doing exactly that yet. Hopefully we start seeing it more and more.
Yeah, same with us. As I mentioned, SCA and Semgrep has been helpful for supply chain or secret scanning and third-party dependencies, but in general, for flagging malicious open source libraries, it's a bit tricky because it's not easy to determine whether a commit is malicious or not. It could just be some code sitting there, and at the back, it could be mining or doing something else, but it's looking at a code, it's not really easy to determine whether it's malicious or not. So yeah, that's a very contentious topic and something that definitely needs exploration further.
Yeah,
All
and
right.
that's, I guess, speaking back to my experience coming from IT and information security now to software supply chain security. It for whatever reason, it's reasonable for system administrators to tell users you can't download whatever you want. But when it comes to software developers, they seem to be very, very sensitive when you start touching their environments and their tooling. And so, if you maybe you have too many false positives in your malicious dependency detection, you're very quickly going to lose a customer, or your developers are going to lose trust in their security engineers. So,
All right. Well, in theory, Hamil, we are gaining more visibility into the problem with the rise of SBOMs. So that's a good thing. But when I talk to a lot of folks, and I think one of our attendees has a similar point, um, I wind up with tens, hundreds, thousands of SBOMs. How do I kind of operationalize this stuff in a way that is meaningful to me? And how do I know that the SBOM is current? Because, well, the application keeps being updated by you developer folks almost, if you're a DevOps fanatic, once a week.
Yeah.
So how do I manage this?
Yeah, that's a good discussion we usually have at our company as well. And for folks who aren't too familiar with SBOM, right? Like SBOM basically just gives us detailed information about components, dependencies in your software application, right? It just does not include something which your company is building, but also includes open source components, libraries, artifacts, stuff like that. So it kind of gives you a graph for a given package, which artifacts are consuming those, both upward tree and a downward tree. So SBOM is quite important, I would say. But operationalizing SBOMs or using SBOMs at large scale and integrating with your organization is quite a challenging task because, as Mike mentioned, and as the question says, right, the size of an SBOM grows. And if you're building an artifact, the same artifact on a daily basis, I would say the delta between both the artifacts would be 1% or 2%. Rest of the artifact or rest of the packages remain the same. So that's where some of the new initiative or the open source tool called as Guac comes into picture, where it is able to ingest these large SBOMs and provide you a graph database. So basically, it gives you a way or an insight to figure out, given a library or a package, which of the artifacts are currently using it, what version of the artifact is being used, what are the license associated with it. So that's quite important, I would say, to give you a posture of where things are at your company. But along with that, I would say integrating generation of SBOM as part of your development workflow. So integrating it as part of your CI/CD pipelines, generating it when you're building your software applications is quite important. And then you have policies around it. So you have policies which can enforce generation of SBOMs or compliance with security, licensing, quality standards, things like those become quite critical.
Kyle, do you have anything to add to that? I mean, is there ways to apply automation to SBOM that maybe will help us going forward here? But I feel like, we all declared that this is the solution, but we don't know how to manage the cure.
yeah, that's a good way to put it. SBOMs, we have a long way to go, I think, before they're as effective as people want them to be. In the current state, there is still a lot of manual work that needs to be done, which makes it totally just unrealistic, especially for those more cloud applications that are changing maybe on an hourly basis. So if you're not automating that, there's no feasible way to keep an SBOM up to date. But then there's also the question of what what should make up an SBOM. Is it just the third-party package dependencies? Is that only open source packages? Does it also include internal packages? Does it include environmental dependencies? Does it include the operating system? My joke is always software supply chain is so vague that, coffee is probably the supply chain security's biggest issue right now, just because every developer needs coffee to write code in the first place. But what I appreciate the most from SBOMs is I actually have a blog post called SBOM, the gateway drug to software supply chain security, just because everybody seems to have heard it. But before that, nobody would have heard of software supply chain security. So every conference, every networking event I go to, I tell them I work in software supply chain. They're like, oh, you mean like that SBOM thing, right? And I'm like, okay, it's like in the current state, the SBOM is probably the least useful thing that I deal with on a day-to-day. But yes, that's it. Thank you. I'm glad you've heard of it.
All right. I think that was your pet.
Yeah, and I think to add to what Kyle mentioned, right? Like even I'm skeptical about SBOM because how do you trust an SBOM? Like if you're getting an SBOM from an open source vendor, a licensed vendor or open source project, right? What if the licensed vendor has removed some known vulnerable packages and are shipping it to you? And given the sheer size of SBOM, if a package is pretty large, it goes to around 300 megs as well. How do you transport that? So I know there's an executive order in place to generate SBOMs by 2024, but there have not been any further updates on this. Like, how do you transport the SBOMs? How do you trust it? And again, as Kyle mentioned around the format of it, there are few major formats which are used for generating SBOMs, but again, what goes in that SBOM is not quite clear. So yeah, I think we still have a long way to go before we actually can use an SBOM to determine what's the health of your organization or an artifact.
Yeah, and then to take it a step further, I believe the executive order requires that those SBOMs have VEX support.
Yeah.
And so with VEX, it's really up to the security engineers or whoever's maintaining that SBOM to then go look at all the vulnerabilities and find which ones are actually relevant to their environment, which ones are potentially exploitable or definitely exploitable or not relevant. So from a vendor risk perspective, like, are you really going to trust the vendor who says, we have 1,000 vulnerabilities, but they're not relevant to us just based on our review? So now it's a really big trust game. And until there's more automation where you can build in assurance, it's kind of, I see very little value in it because I just don't trust anybody. That's maybe a me problem.
I think that's called good security. Well, speaking of not trusting anybody, I mean, Hamil, I don't know if you've seen this or people are talking about it, but most of the people I know who are maintaining open source packages are kind of desperate for help, right? They're basically, anybody who can help me contribute to this thing would be awesome, and please help us, et cetera, et cetera. But it's not clear to me they always vet who's making those contributions, and it seems to create an opportunity for some, shall we say, enterprising malicious actors to go start contributing software to open source projects that has malware deliberately in it, and we don't always scan for that malware. So do we need to have a bigger conversation with the maintainers of these packages about what are the best practices for security? Because, for the most part, it's not something that's on the front of their brain.
Yeah, and that's where DevSecOps teams and DevSecOps play a critical role, especially for open source projects. So we need to have some basic checks in place, and there have been recent incidents, right? Like I think there was a university which was, I don't remember the name, but where they were committing malicious code, and then eventually they were blocked because it was noticed they were publishing malicious code to a particular repo. I see Kyle smiling, so I guess he knows what I'm talking about.
I forget the name of the university, but if it's the one I'm thinking of, were they contributing to like the Linux?
Yeah, they were, and they got banned from contributions because they were doing it as a quote unquote experiment to see if it could be done.
Yeah. So things like those are something where we need DevSecOps to come in and make sure that to at least have an inventory of what's happening with the open source project, and again make sure we we have tools like, so if you are using GitHub, where most of the open source project is, you have Dependabot, which makes sure you are using the latest libraries. You do static code analysis to identify coding errors or security vulnerabilities in your open source components. You add in security controls for container runtime, so enforcing least privileges, isolating workloads, some basic housekeeping to make sure at least the open source project is maintainable and easy to use for downstream users. And on top of it, there are things where maintainers of the open source project needs to also look at, for example, threat modeling, threat assessment of their project, things like those.
Yeah. Sometimes I feel like software supply chain security is really just a buzzword for DevSecOps. It's and we're starting to see that a lot of those risks come to light, especially with like GitHub Actions and just maintaining a GitHub repository effectively and securely. Even something as simple as having MFA for your NPM account was something that was super controversial a couple years ago, where we actually saw package maintainers take their projects off of NPM just because they didn't want to configure MFA, which is concerning to me. And now we see Python. Now they're requiring MFA as of, I believe, January of this year. So we're starting to see progress there. But GitHub Actions and all that infrastructure that developers rely on for the build process is apparently full of potential security gaps. And so hopefully we can patch those up before the malicious actors really start to take advantage of them.
Kyle, how aware are IT leaders about this? One of our attendees has a question here about, do you think that the senior leadership in these organizations really understands the risks, or are they just basically, hey, we got the software, it's done, and away we go, and no one's taken a minute to go, what did we just agree to do?
It's really tough. I think they've hopefully heard of it, especially now with the executive order. I think is when people really came to understand, like, hey, we're eventually going to need to generate these SBOMs, and our customers are likely going to ask for these SBOMs. We don't want them to be full of vulnerabilities. We don't want our customers to see that our code is using all of these vulnerable dependencies. It's not good for reputation. It's not good for security risk or hygiene. So now it's something that's on top of everybody's mind. But where it becomes interesting is really the business decisions in this, because we've gone how many years or decades now with developers just being able to install whatever dependencies they wanted. If we start to restrain that a little bit, what are going to be the business impacts? Are developers going to be less efficient? Are they going to, maybe they'll write more code themselves as opposed to using a third-party package, which might introduce more vulnerabilities because now they're using their own custom solution as opposed to a standardized one. So,
Hamil, I don't know if it's different at Yahoo, but there seems to be a general reluctance still to patch applications for fear of things will break. So when we have these issues, how do we kind of know what's the level of risk that we want to take on versus maybe breaking the application? Or is the risk now greater than the cost of breaking the application?
Yeah, I think it's a bit tricky, right? The risk was always there. It's just that with open source, it's been more visible. With so many tools coming in, we are able to catch these risks much more sooner in the pipeline than when it was discovered in the past. So now as it comes down to business decision, where do you want to move fast and break things, or do you want to make sure that you want to do the right thing, build it, ensure there are no open vulnerabilities, and then move ahead? But as a security expert, I would obviously like the latter part. But as a business or a product guy, I would want to go to the market as soon as possible at the cost of maybe not patching some of the open vulnerabilities. So that's where the leaders and the execs come into play to decide to gain, basically to do risk analysis to determine whether is going to market more important or having the right security fixes in place more important.
Yeah, I've found there, there are some ways to kind of manage that risk on whether a patch or an update will introduce breaking changes, relying on things like semantic versioning, which if projects actually adhere to semantic version specifications, there's patch fixes, there's minor fixes, and then there's majors. So the minors and patches shouldn't, by definition, introduce any breaking changes. So ideally, if the update that you need to make in order to remediate a vulnerability is a patch or a minor update, you should be fine to just go ahead and do that. It's not always the case. There was a study for the Maven ecosystem where the packages in the sample adhered to semantic versioning roughly 80% of the time. So 20% of those that shouldn't have introduced breaking changes actually wound up doing so. So there is still a risk, but hopefully much lesser, and maybe that's more reasonable from a business decision making process.
Hamil, you mentioned DevSecOps earlier, and I'll dive into that a little bit more, but who's responsible for this? Because the security people always think it's the developer's fault, and they sit around and they go, clearly all our issues can be traced back to faulty software. The developers, are told that everything's going to shift left, but they look at all these alerts, and none of them went to any kind of cybersecurity training. It was generally an elective for most of them, if they took college courses at all. And so they get overwhelmed with these alerts, and the cognitive load is too high, and the alerts don't mean anything to them. So between those two extremes, how do you set this up so that we can succeed?
Yeah, so I would talk from my experience at Yahoo and how we've been doing things. So there has been a huge focus on securing through practice. So basically, we have deputies who are always incentivized to bring best practices of security to their orgs, and we do a great job promoting not just the folks which are under the security org, but product teams and development teams to come in on a weekly or a monthly basis. We give them the top down on what are the important alerts, what are the things which, as a security expert, we are looking for in their particular product, and they are advocates within their org. So if it's coming from someone within the org versus someone coming from security, the weight factor becomes different, because someone you're working on day in, day out, if they are more concerned about security, people would tend to be maybe more receptive to what they are saying. So I would say that's one practice which has been proved to be good for us in the past, where the developers are the ones advocating for better security practices. Along with that, the other thing we do is when a new product or a new tool is being used, we always do a security review of the product to look at any open issues, do a detailed threat modeling, which makes sure that both the product team and the security team are aware of the risks, the architecture, and the dependencies of that particular product. So there are some guardrails which we have in place. Along with that, we again make sure we implement secure coding practices and guidelines for developers. There is secure code training, which happens on a regular basis, where developers do the secure code training, so they know what is CSR, the top 10 web attacks which are possible, and then they code accordingly. And again, AI is quite helpful. We've seen in the past recently with Copilot coming in, the suggestions and the autocomplete and auto review with AI, it is quite helpful. Again, it can be taken as pros and cons. So it's been quite helpful for adding unit tests in place, code reviews for secret scans, and bad coding practices. So all these, I feel, we are going in the right direction. It's just a matter of time when we can achieve the golden state which we are looking for. So yeah.
All right, we got to the 42-minute mark without mentioning AI, so there you go. Kyle, is AI going to save us from ourselves? Do we have enough data to kind of drive these models, or what's your sense of what is the maturity curve of AI?
That is a loaded question. I will say that my background is pretty much exclusively cybersecurity. I was never a software developer. I never wanted to be. AI has made me feel like I can be a software developer. I don't know if that's good or bad. I think like reviewing a lot of what it produces with a strictly a security mindset is concerning to me, but I also understand we're in the early stages. And I do see a lot of the benefits of using AI in security tooling. One thing so with Semgrep, we have Semgrep Assistant, which is like our AI solution that's baked into the SaaS product. And so what I've found interesting in our usage is it's not used necessarily to produce results. It's kind of used to argue with our own tools results. So we say, hey, you have a vulnerability in your code here, and AI then reviews that, focused just on the context of that vulnerability, and says, hey, actually, Semgrep Assistant thinks this is a false positive. It's like, so we use AI to basically find the flaws in our solution, which I find to be a unique approach.
Hamil, are we too quick to blame each other? Should we think more about how we're going to collectively solve this a little bit? Because I think in a lot of organizations, there's always this sense of, from back in the days when we would have, war rooms where everybody would be basically walking around going, yep, I proved my innocence so I can get out of the room. But I mean, collectively, do we just need a different mindset here?
That's a interesting question, I would say. I'll have to think a bit about that. Maybe Kyle can answer that. Let me collect my thoughts there.
Yeah, another loaded question. It's I think coming at this from a relatively fresh perspective, I think kind of the foundation of it all is the source of the problem. It's people being too used to old ways. Like I was mentioning earlier, being able to download whatever dependencies that you wished, kind of just trusting people on Stack Overflow and now ChatGPT, and really maybe the initial mindset of open source being more secure than non-open source. I do think in most instances it is, just for the sole fact that there's more eyes on it, and it's more of a community-driven effort than one focused on financials. But there's also a lot of poorly supported packages that are in the open source realm, and we see this reviewing customer dependencies and just even open source projects and their dependencies. A lot of the packages they rely on haven't had a commit in 5 years, 10 years. There's a lot more than just vulnerabilities that need to be considered. There's what we often refer to as dependency health. So evaluating, is this still a well-maintained project that we can trust to be secure? Because no researchers are going back looking at code that hasn't been touched 10 years ago and pointing out all the vulnerabilities in them. So another way, if you don't want any vulnerabilities, use projects that haven't been touched in 10 years. More bad advice coming from Kyle.
Yeah, and I think just now that I've as Kyle mentioned, right, like thinking about it, what we do is instead of directly going to open source, we have a proxy. I think someone mentioned in the past, maybe it was Kyle who said having a proxy helps. So we have a proxy where we mirror everything open source internally, so we aren't dependent on internet. So as part of a CI/CD, we always have a proxy. We pull it from our mirror images. And along with that comes the question of end of life. So like if a library or an open source package has not been maintained for certain years, so 10 years, for example, then you declare it like an end of life for that project, and then there is no one who's maintaining it. So as security engineers, you tend to have a list of libraries which are no longer maintained or not fresh enough, and then you slowly transition it out, because it comes as a question, like when I'm a developer, I might pull a library in, and because it was my need. But now 10 years later, since that library is no longer maintained in open source project, should I be the one maintaining it internally to make sure they have no other vulnerabilities? Who is responsible for maintaining those pulled in open source libraries? Is it the responsibility of the developer who pulled it for the first time, or is it the responsibility of the developer who last used it, or is it a security professional who's going to take care of this. So end of life and maintaining that internally is a big question, and that's where the trust comes in, where you expect the developers to do the right thing and make sure that they patch all the vulnerabilities and maintain it internally. But developers leave, teams change, priorities change. So like you need to have policies and guidelines in place when this happens in the future. So yeah.
So Kyle, do we need something that feels like, you've seen some organizations do what Hamil just described. They kind of get wrapped up into something called like the open source program office or something like that. And they govern both their outbound contributions to open source, but also their inbound consumption. And is that the kind of set of best practices we should be thinking about?
I mean, until there's more solutions out there that do a lot of that work, I think inevitably that's kind of the only real effective solution these days. One thing that I'm always curious of, Hamil, hopefully you could shed some light on this though, is when it comes to supply chain security or managing open source security risks, what I find oftentimes is that companies only care about the risks relevant to their products, the things that customers actually receive, and less so when it comes to internal development. Do you see that you apply the same level of security to both internal projects and consumer-facing ones?
As a matter of fact, yes. So one of the projects which I'm leading is around scanning. So basically, we want to make sure every artifact or a container image which we are building, basically a container image would contain both the open source as well as proprietary code. We want to scan all those container images to make sure it does not have any vulnerabilities. And then once we have a list of vulnerabilities, right? So for example, we use open source tool, not to just pinpoint one or two, but some of them which we have used is Gripe and Aquasec Trivi, which gives you a vulnerability JSON of the container image which you are building. And once we get that information, we compare it with the vulnerabilities which we at Yahoo really are looking for, because not all vulnerabilities are what can be easily exploitable. So like as a vulnerability management team, you want to make sure you don't have runc or log4j shell or NSS, whatever the CVEs which we care about. And during the build time itself, before we publish that to Artifactory or before we are using it into production, we want to make sure those images do not have any of these known vulnerabilities. So we divide it into two parts. One is the build time scanning, where we ensure there are no known vulnerabilities during build time. But now, let's say maybe a week later, we are trying to deploy that image in production. And within a week, there has been a new vulnerability which that image had. So we also have checks during deployment time, which ensure, or we scan to make sure that that image does not have any new vulnerabilities as well. So we are trying to reduce the exposure we have for at least vulnerabilities and artifact corruption. So we don't want, let's say, a bad actor gets access to a system, and you don't want them to replace a signed trusted artifact with a bad or a malicious artifact. So we do signature verification during deployment time as well to make sure that we are having these checks and policies during deployment. So we trust what we are building is what we are deploying in production. So again, it's not just limiting to open source.
Yeah, I know you mentioned Gripe and Trivi, and so follow-up question on that. Do you find, I know in my experience, if a project adheres to build reproducibility standards, it's a lot, SCA and all these tools out there for vulnerabilities are a lot more effective. Do you find that containers are a lot, like, in my experience, they've been a billion times easier to work with from a software supply chain security perspective than other types of projects?
Yep. Yeah, and I think that's a push we have to go more towards containerization, where you could do all of these checks, scans, and they're lightweight. So it's easy for us to replace them as well versus traditional bare metal, or where you need to build AMIs and there aren't many tools in place to scan those AMIs, to be honest, right now. Gripe and Trivia are more focused towards container scanning. So yes, containers is what our focus is, and that's where we put most of our energy there right now, for making sure we have no security context, no one is running as a root user in a container image, things like those, right? So yeah.
All right, guys, we're coming down to the last couple of minutes. Kyle, what's your best advice to folks right now as you kind of wrap this up? What do you see people doing that you wish they would stop doing?
Really just blindlessly using dependencies is probably the biggest one. I think when I'm writing code or even when I'm using ChatGPT and Stack Overflow, I'm maybe a safer developer just because it's always, it's built into my brain at this point. And so kind of like the whole shift left mantra, I think really developers, if they just know that this is a thing, well, maybe without even knowing, start to practice it. It's not all that difficult. And the developers oftentimes want to be using the latest and greatest dependencies. So something that we talk a lot about internally is how can we, when making recommendations on using new dependencies or replacing vulnerable dependencies, how can we get the developer excited about it? So maybe the latest major upgrade that remediates all the vulnerabilities also comes with a 30% performance boost. That's something a developer would be happy to install. So,
all right. So we need more public service announcements to educate people about the various things that can harm them. Hamil, closing thoughts here, a couple of minutes.
Yeah, I think just to echo what Kyle mentioned, like locking down third-party libraries or reviewing and updating external dependencies, and also continuously monitoring and doing a security review of your code base to make sure there are no vulnerabilities. So static code analysis tools, vulnerability scanners, maybe security-focused CI/CD pipelines to basically automate your security checks are something which, yeah, I think those are basic things which we can do to protect ourselves from these, because this is inevitable. Sooner or later there would be vulnerabilities in open source project, and you can't have checks to make sure all of those are covered. Whereas if we build a secure pipeline or we have secure SDLC, that's where most of the attacks can happen. So focusing on secure SDLC is what I would say.
All right. It's as important to know what you're going to do after you encounter the problem as it is to prevent it in the first place, because there's no such thing as 100% prevention. So there you go. Gentlemen, thank you for sharing your thoughts and insights.